So we have a cylindrical hole through a cube. So I'm going to start with surface area of the cube. And with that, I can touch the whole cube except for these two circular bases, because that's a hole running through that cube. So if I do 20 cubed, or sorry, not 20 cubed. If I do 2 times 20 squared plus 2 times 20 squared plus 2 times 20 squared then I would need to subtract. I have 2 circles, so 2 pi, and the radius of those circles is 3, so 3 squared. So the surface area of the cube, if I do 2 times 20 squared, 3 times, that's a 2400, and then I would need to subtract 18 pi from that, and that's just the surface area of the cube. But then I can stick my hand through this and touch the lateral portion of this cylinder. So I'm going to do the lateral area of the cylinder to find the surface area of that cylinder. And that's just going to be 2 pi r(h). So 2 pi times the radius of 3 times the height of that cylinder, which is 20. And so a 20 times a 2 times a 3 gives me a 120 pi. And I would add these together. So if I asked for the exact surface area, you would give me 2400, and then a 120 pi plus a negative 18 pi is a 102 pi inches squared, which is approximately equal to, if I asked you to round, 2,720.44 inches squared. All right, so for this one, volume's pretty simple. I take the volume of the cube and then I'll subtract the volume of the cylinder, and that's it. So the volume of the cube is going to be 20 cubed, which is 8,000. And then I'm going to subtract the volume of the cylinder. And the volume of the cylinder is pi times 3 squared times 20, which is a 180 pi. So if I asked you for the exact volume, you would just write it as 8,000 minus 180 pi. We cannot combine those two together because the 8,000 doesn't have a pi on it. If I asked it for the volume rounded, then you actually type it into your calculator and you would get this. All right, moving on. We want to find just the surface area of the following figures. So for this one, I have a triangular prism, and with that triangular prism, and sorry, this is hard to see, it's a right triangular prism. With that triangular prism, I have a cylindrical hole going through, and the diameter of that cylinder is 4 centimeters. So this one's very similar to the one we just did. I'm going to do the surface area of the triangular prism, and that is going to be the height of that prism, which is 14, times the perimeter of the base, which is 5 plus 5 plus 7.1. So that's a 17.1. Plus 2 times the area of the base. It's a triangle, and it's a right triangle with these two as legs. So 1/2 5 times 5. And then I'm going to need to subtract the surface area of these two circles, because that's a hole running through, so I can't touch those physically. So I'm going to subtract 2 pi, and my diameter is 4, so my radius is 2 squared. So I wind up with a 14 plus a 7, a 14 times a 17.1 plus a 2 times a 1/2 times a 5 times a 5 is a 264.4. And then I'm going to subtract a 2 squareds of 4 times a 2 is an 8 pi. And then I would need to add on the surface area of the cylinder, which is only going to be the lateral area of the cylinder, because I can touch that cylinder inside of that triangular prism. So just doing the lateral area of the cylinder, that's 2 pi times my radius, which is 2, times my height, which is 14. So I wind up with the 56 pi. And then I would add that together. If I asked you for the exact surface area, you would write 264.4, and then a -8 plus a 56 is a 48 pi, so plus a 48 pi. If I asked you for the rounded version, you would type that into your calculator, and you'd get about this. Actually, it would be 20. And they just asked for the surface area, so that's all we're doing there. Okay, same thing for the next one. We're just finding the surface area. We have a cylinder that contains 2 congruent hollow cones, and if the cylinder's height is 20 and its diameter is 14, meaning that the radius would be 7, we're going to find the surface area. So on the cylinder, we can't touch these 2 bases because there's 2 hollow portions there. So we're just going to find the lateral area of the cylinder to find the surface area of the cylinder. So the lateral area would be 2 pi times my radius of 7 times my height of 20. So for the cylinder, I would get 280 pi. Now these cones are indented, so I can actually touch the lateral areas of these cones, and there's 2 of them. So to find the surface area of the cones, I'm going to just do the lateral area, and I'm going to multiply by 2. So that's a 2 pi times your radius times the slant height, which we would need to find. So I'm going to use that 7, and then halfway down would be 10. So I'm going to use 10 and a 7 to and do the Pythagorean theorem to find out the slant height, which comes out to be approximately, oops, let me write it this way, approximately 12.21. So that's what I would write here. So I already rounded, so I'm just going to round my final answer. So the surface area of the 2 cones is about 537.02. And so then I would add these 2 together. So 280 pi plus a 537.02 comes out to be approximately 1,416.67 inches squared. All right, that brings us to the end of this video.